Alright, we have a few more slides left. Let's talk about this. So we have domain and range, which is our next group of describing factors. We need to describe the domain using all of our x's, and our range is all of our y's. So the domain is all of the input values, the range is all of the output values. So think about all of the x's that the graph is touching and all of the y's that the graph is touching, or using, not touching. So we're going to write it using more notation. So again, think about this is the beginning point, this is the ending point. Starting value, the first thing in the notation is the beginning, last thing in the notation is the ending. So domain is all of your x's, range is all your y's. Domain is left and right, range is x and or up and down. So think about this graph. If I'm talking about this graph left and right, left it's going down and it's going to use all of these values. Right, it's going to be going up and it's going to use all of these values. So currently, if I were to point at each one of these numbers, at -3, we can go down here and it's going to hit the graph right there. At -1, it's going to hit the graph right here. At 3, it's going to hit the graph right here. At 7, it's hitting the graph. At 8, it's hitting the graph. So if I'm looking at all of these x values, because these arrows are going to continue, it's going to use every single one of those negatives. And because this arrow is going to continue this way, it's going to use every single one of these y's. So if you were to think about any number, 50, if I were to go all the way over here and graph 50, this line's going to keep going up and it's going to wind up hitting 50 like somewhere up here. So I'm going to say all of my numbers work for my domain and range, because going up and going down, all of these are going to work the same. So infinity to infinity, or negative infinity to positive infinity. For this one, again, if I look at the left and right, this is going to keep going up, right? If it keeps going up and up and up and up and up, it's going to use all of these negative numbers. And if this one keeps going up and up and up and up and up, it's going to use all of these positive numbers. So again, all my numbers for my domain. My range, however, if I'm looking at this blue line, these are going to keep going up, so it's going to include all of those, but is it going to go any lower than this? No. So the lowest it can go is -4 through all my positive numbers. Okay, my domain here, again, all my x's. Is it going past this? I have it at -2, but it should be -2.5 is what it looks like. So -2.5 all the way over to a +3. Those are all the x values I can use. My y's, it's going to go from -10 all the way up to +16. Those are all the y's I can use. There are no arrows here. Again, notice when there's arrows, I'm using the word infinity because it's going to keep going. When there's no arrows, I'm not using the word infinity. I'm using an actual number where it starts and stops. Notice there's one arrow here, so I'm going to be using one infinity, but there's also a stopping point or a starting point at 0. So left and right, it starts at 0, up and down, it starts at 0. So I'm starting at 0 and I'm going to positive infinity. These are my domain and range. The next one is continuous or discrete. This, like the shape, is very easy. A continuous graph means it forms an actual line, whether that line is straight, whether that line starts and stops, whether that line is curved. As long as it is a solid line, it is continuous. If you have a discrete graph, that means you just have a bunch of random points. Those points could be in a straight line, those points could be in a circle, those points could be in a curve, or they could be sporadic. However, when they are just a bunch of points, it is a discrete graph. When they are a continuous line, it is a continuous graph. The last one is function or not a function. So first of all, let's looking at this left side. It says you're going to use what's called a vertical line test. If you were to hold a vertical line at any point in time in your graph, it should only hit one single point. So if I draw this line, it only hits right there. If I draw this vertical line, it only hits right there. Vertical line only hits right there. If it only hits one point at a time, it is a function. However, if I draw a vertical line and I notice that it not only hits 1 point, but it hits 3 points, 1, 2, 3, then it is no longer a function. So over here I have a bunch of examples of stuff that are and are not a function. This straight line is going diagonal, which means at any point in time, if I were to draw one line on there, it's only going to hit at one spot, so this one is a function. Same thing with this one, vertical line test. If I draw a vertical line, it should only hit at 1 point. This one is a vertical line, which means it's hitting every single point on that graph, so it is not a function. Same thing right here, it is a function because if I were to draw one line, it's only hitting at 1 point. This one would not be a function because it would hit at both of these spots. Function, not a function because it's going to hit at 2 spots. Same thing here, it's hitting at 2 spots, which means it is not a function. Okay, these are all of our different things that we have to go through every single time. So on your example, if this was your homework or if this was your assignment in a minute, it's going to ask you to fill out every single one of these. So let's do this one together. So we have this graph over here. Shape. It looks like a, let's see, upside down. Let's see if I can spell right. Upside down V almost, right? Alright, now we're going to do a line of symmetry. Is there anywhere where I can just draw a straight line and that graph will be exactly perfect or exactly matching on both sides? Not in this graph. There's no spot where I can draw an exact line and both sides match up, so there's none here. Alright, so now we're going to talk about increasing and decreasing. So let me go with increasing first. So where is it increasing? So again, if I'm looking at it from left to right, so from left to right, I go to this point, it's increasing from here to here. So it's increasing from -4 all the way up to 0. So it's increasing from -4 to 0. Okay, now decreasing from 2 to 3. Oh, 2 to 4. Decreasing from 2 to 4. Maximum and minimum values. Okay, well minimum, lowest it can go right here is at -4. So let's do this again. Minimum value is at -4. The highest value it can go is right here, which is a +5. Intercepts. Is it crossing this x-axis at any point? It is not. So for x-intercepts, let's see, x-intercepts, we have none. And for y-intercepts, we have, where is it hitting y at? Right here at 0, 5. Almost done. Domain and range. So domain again is x. So x goes from -4 over to +4. So your domain is from -4 over to +4. Your range is your y values, so highest and lowest. Lowest it can go is 1, highest it can go is 5. 1, 5. Alright, is it a straight line or is it a bunch of points? It is straight, so it is continuous. And if I did my vertical line test, would it only hit at one point? Yes, so it is a function. That's your example. If you need more help, let me know.